So we'll go ahead and look at the implementation of a stack in Java. So what I have defined, if you are aware in Java, you might have already encountered a class called stack, which is predefined in the Java libraries. But since we want to learn how to create a stack, we will not use the library class. Instead, we will create our own custom stack class. So first we create a custom stack interface. So this custom stack interface, it defines all the methods that you want to declare for a stack. As we had discussed earlier, the primary functions are push and pop. A push basically should be able to insert an element onto the stack. So it takes a variable. It takes a generic variable and it gives you the flexibility of inserting that. And since we don't expect any return type in it, so we have a void return type for the push method. And since in a push method, you might encounter a scenario where the stack is already full and you are trying to insert a new element to the stack. So that might lead to a stack overflow error. So stack overflow error indicates that the stack is already full and you are not allowed to add any more elements to the stack. So you should ideally throw this stack overflow error. So this is how a signature of push should look like. Similarly, in pop, you should be able to delete the element from the stack. And since you are deleting that element, you should have the access to that element as well. So it returns a generic data type. And there can be a scenario where the stack is empty and you are trying to delete an element from the stack. So in that scenario, you should throw an empty stack exception. So this is how a signature of pop should look like. I have defined two other utility methods in my custom stack interface, which is isEmpty and getSize. So isEmpty just lets you know whether the stack is currently empty or not. So isEmpty will return a boolean. If it is empty, it will return true. If the stack has elements in it, it will return false. Similarly, getSize returns you an integer, which indicates the current size of the stack. If the stack is of size 0, it returns 0, or if the stack is of size say 5, it returns 5. Now we go ahead and implement this interface. So this is a class where we are implementing this interface and creating a custom stack. So the first step is like, how do you want to define a stack? Whether you want to use an array or a linked list. There are two ways in which you can create a stack. So either you have an array wherein all the elements will be adjacent to each other, or you have a linked list where you will have a reference to the next adjacent element. Since we are yet to take a look at linked list, we will go ahead with the array implementation of stack. So the first step is we create an array of objects as a variable and store it in the class. Then we have another variable called current size, which keeps account of the current elements in the stack. And we have another variable, max size, which gives you the maximum permissible size of the stack. And as you can see, we have provided two constructors within the stack. One which takes an argument of the max size, another which creates a max default sets the max size to 100. So the constructor just creates the class of size 0. Now we go ahead and try to implement the push method. So the first step of any push method should be to check the current size of the stack and match it with the maximum size. if the current size of the stack is greater than or equal to the max size, it cannot be greater than the max size definitely, but if it is equal to the max size and you are trying to do another push, you should throw a stack overflow error. And if it is less than, you should be able to insert the object in the stack and then exit. So how do you insert an object in the stack? Since you already have defined the array, this dot stack array, so just add to it to the current size of the, just add that object to the current index of the stack array that you have created and increment the current size. So this is just a simple code which implements the push elements to the stack. Now, as you can see, it doesn't take much time and it follows. It has a time complexity of order 1 since you are trying to insert an element into an array with its given index. So the time complexity is of order 1. Now, similarly, we go ahead and implement the pop method. In the pop method, the first step should be to check the current size of the stack. So if the current size is 0, you should throw an empty stack exception. If the current size is not 0, you get the current size and then pop this element from the stack. So for pop, you just take out the element at the present in the current index and then set the stack array to null and decrement the current size. And then the object that you have created earlier, you should return this object from this method. So as you can see over here, since we are just accessing an array based on its index, it follows a time complexity of order 1. Now similarly, as we have defined earlier, we have defined isEmpty and getSize methods. So isEmpty, it should just check the current size of the stack and return true if it is 0, else it should return false. Similarly, getSize should return the current size, and there are few private methods which we have defined to access the to help various other methods. So as you can see, there is nothing much in this stack implementation. It's just that you have to follow the basic design principles of which exception to throw and how to change the index variable index of the array and access the array via its index so that the time complexity remains order 1. We change this custom stack slightly and we go to try to implement few other advanced features in the stack. Let's say you want to find out what element is at the top of the stack. You don't want to delete the top element, you just want to check the element, last element of the stack, or rather the first element of the stack. So we define a new variable, new method called p. So you should be, this gives you the flexibility to view the element in the stack without deleting it. And we have defined other few advanced methods in the stack, such as getMin or getMax. GetMin basically it returns the minimum element in the stack without deleting any element from the stack. And similarly, getMax, it returns the maximum element from the stack without deleting any element from the stack. So we go ahead and take a look at its implementation. As you can see, first we'll go ahead and take a look at P. The other methods we'll take a look later. So as you can see, here basically P returns a data type of what you have defined earlier. So I have defined this class for integers, so it returns a data type of type integer. So, and again in the same fashion, if the stack size is 0, you should throw an empty stack exception, or else you should just return the current index. You should just return the element at the current index of the array without deleting it. If you remember,
pop, we used to delete this, delete the element present at this index. Now we are not deleting it. We are just returning this element at this index. Excuse me. Now similarly, since we have defined get min, so that is slightly complex. We will go ahead and take a look at how to implement the minimum variable of a stack. So let's first try to understand what this get min function does. Let's say you have an array which has integer elements, which takes integer elements, and let's say you first add 5. So you have an array with an element 5. So what is the minimum of the elements in an array? It's obviously 5. Now you say you add 10. So you have you have a stack with elements 5 and 10. So the minimum of 5 and 10 still remains 5. So if you want, the get min function should return 5. Now let's say you add 3 on top of it. So you have an array with 5, 10, 3. So get min function should return 3 now instead of 5. Now let's say you add 1 on top of it. So get min function should now return 1. Now if you add 2 on top of it, get min function should still return 1. And if you add 7 on top of it, get min function should still return 1 because that's the minimum. Now let's say you start popping the elements. You pop out 7, the minimum still remains 1, so you are fine with it. Now you pop out 2, so the minimum still remains 1 and you are fine with it, you are returning 1. Now let's say you pop out 1. Now since 1 is not part of the stack anymore, you cannot return the 1 anymore. So you have to return 3. So 3 is what is now the new minimum of the stack. So you need a data structure to store this whole list of minimums. Now let's say you remove 3, the minimum becomes 5. So you cannot have just a single variable to store the minimum of the array because that is dynamic. Once you start popping, the minimum gets changed. So you need to keep a track of all the minimums at any point. So the best way to implement this is to have another stack within the stack which keeps track of all the minimums. Let's say you have added 5. So the minimum is by default 5. So you add this 5 to the minimum stack. Now you add 10 and you see that the minimum is still 5. You don't add any element to the stack. Now you add 3 and the new minimum becomes 3. So you have to add 3 to the stack. Now you add 7. The new minimum is still 3. You don't add anything to the stack. Now you add 2. The new minimum is 2. So you need to add 2 to the stack. Similarly, if you add 1, you have to add 1 to the stack. Now in case of pop, whenever you are popping an element, just ensure that the minimum also gets popped if they are equal. So you pop 1 from here, and since 1 is what is in pop, so you have to pop 1 from the min stack as well. So this is how you keep track of all the minimums within the stack. Let's see how we implement it. So this is the min stack that we have added within our stack class. So as you can see, whenever we are pushing an element into the stack, this is our earlier implementations where we add the element to the stack array and then just increment the size. Now we try to populate the min stack. So first step obviously should be, if the stack is null, create a new min stack. And at every stage, you have to check you have to pick the last element of the stack. And if it is greater than the current element, just push it to the min stack. So this is what we are doing over here. So this is the implementation of push, where we are pushing elements to the new min stack. And similarly in case of pop, whenever we are doing a pop from our existing stack, we go and take a look at the min stack as well. And we do a peek on it to check if the element popped from the first stack is same as the element extracted element on the top of main stack. If they are same, we do a pop on the main stack as well. So it's as simple as that. And since we are using just push and pop, so the time complexity remains of order 1. You can download this source code and check the implementation and run the test cases that I have defined in custom stack test to just find out the minimum at every level. Similarly, in the same fashion, you can create a max stack. That I'll leave as an exercise for you. Guys, try to implement a max stack function. The way we have defined getMin, just implement a get max function by creating a new max array. That is all that we have at the basic level to understand the basics of stack data structure. We can go to more complex scenarios. And I would suggest that you go ahead and solve some very complex problems related to stack. If you want to take a look at the real life implementations, I would suggest you try to implement the browser functionality of back and forward. If you go and visit any browser, if you try to access multiple sites from a browser from the same web page, your back button implements stores a stack which keeps track of all your user movements. So that is one of the best use cases of stack in the real world scenario. I would like to conclude this session. And would thank you all for your patience for listening to this class. Thanks everyone. Thanks everyone.